Rory Aronson. So Rory's doing a talk about beyond README.md, and we all understand the importance of the README.md file, an open source, and I've lost my mouse cursor. There you go. But what happens when you go beyond software and begin to document your hardware and your business model too? What could happen if you transform your documentation from a file to a product? In Rory's talk, he tells the story of how FarmBot Incorporated is raising the bar of what it means to have a great documentation and why it's vital to his mission and vision. I give you Rory.
All right, good morning, LCA. Let's get this laptop going here. All right. So my name is Rory Aronson, and I'm excited to be here. I flew in from California to talk about going beyond the README.md file with your projects, with your documentation, and what the ramifications of that could be. So before I get started in the documentation side of things, I want to take a trip down memory lane and set some context for where I'm coming from. So here I am, 2009. I had just moved out of the dorms. I studied mechanical engineering in California, and I'm planting my first garden. So I was excited about being on my own and growing my own food and being self-sufficient. So I went to the hardware store, got some starters, and put them in the ground. And I grew myself a salad. There were many more of these to come. But after a few months, the garden kind of turned to a rubbish pile. Maybe some of you have been here. I got busy with school. I went out of town. I got lazy. I forgot to water, forgot to weed. And inevitably, the garden kind of just went to this. So over the years, I made a few more attempts, but every time it kind of ended in some similar story here. And that's really because gardening isn't my passion. It's not my pastime. I don't really enjoy getting down and dirty, at least not really regularly. It's fun every once in a while, but it's not my passion. So a few years later, I was in the middle of school. I decided to take an organic agriculture class, and I learned about this machine. This is the lettuce bot, which was developed by a company, Blue River Technologies, which was later acquired by John Deere. And this is actually a pretty cool machine. The way this thing works is it has a camera and computer vision software, probably some machine learning on there, and it is constantly taking pictures of the soil and the plants, and it's identifying what green things are weeds and what green things are the lettuce plants, and then it uses a tilling implement to go through and selectively till the weeds under the soil. And I think they also have a version that selectively sprays something to mitigate the weeds. So this is pretty cool. So I'm kind of looking at this and be like, wow, that's neat technology. I'm a technologist, I'm an engineer. I'm pretty inspired by this. And then I'm looking at this, I'm like, well, where's the version for my backyard? How come all I have is a hose where I'm just kind of blindly spraying water? I don't really know how much, and all I have is, a shovel in my hands. Where's the technology that could help me do what John Deere is doing? So I began thinking about this problem. I had some experience with CNC routers, open source 3D printers, and I said, hey, all this stuff kind of already exists. Let's just combine these ideas into something that would solve my problem. So I kind of took the open source framework of 3D printers, 3-axis CNC control, all precision equipment, and I said, all right, well, let's make it plant seeds. Let's make it spray some water out there. We can put some sensors on it. We'll connect it to the internet, and we'll control it from anywhere in the world. And it will grow the garden automatically, in theory. So in 2013, I graduated from school, and I began working on this project more seriously. So I put together a white paper, about 50 pages long, where I described FarmBot. So that's the farming robot concept that is the big 3D printer for growing your garden. So I described the hardware, the software. I'm so embarrassed by this mock-up now. The data, what you could possibly do if you were, collecting data points of the soil moisture content or the temperature every single day. I developed a bill of materials where I kind of did some basic research. I looked at what was out there, some off-the-shelf parts, and I put together this BOM and said, what would it take to actually build this thing? And I took all that and put it in this paper and I open sourced it. So I put it out on the internet under a Creative Commons license, and I said, who wants to help? This idea is for everyone, and I'm a mechanical engineer, but I need software developers and designers and all sorts of people to help make this actually happen. So backing up a little bit, in case you don't know, John Deere is not exactly the most open source company out there. They're actually quite adamantly against it in some regards. So I gotta just be thinking, kind of puts a smile on my face that some higher ups at John Deere are just being like, oh man, like open source, this is kind of ridiculous. Like this thing is, but they're probably thinking I'm crazy, but I don't think I'm not crazy. I just have different values. So, in the open sourcing of FarmBot, I was taking the value of impact and putting it above the value of money, where because what's more important to me is the ability for the work to affect change, more so than the ability for the work to make me money. Now, I'm not ruling out the possibility of the work making money, but I am putting very explicitly the impact above the money. But apart from impact, I also felt strongly about these things: distributed ownership, individual control, the right to repair. You go to the supermarket and you can vote with your dollars on what type of food you want to put in your body and how it's produced. Is it done sustainably? Is it done with certain practices? But it's even better if you can, control the whole process yourself, either by gardening by hand or by, potentially having a machine or an appliance to help you do that. The right to repair, of course, is very important. Having true ownership over your equipment is very important. And one last thing, everybody eats, hopefully 3 times a day-ish. So of course I want to share this idea. It just kind of feels right. If I have food and you're hungry, I want to feed you. That's just a very human thing to do. If I have an idea for how to grow food, and I can share it with potentially millions of people on the internet for free or virtually no cost to me, I should want to do that. I should feel compelled to share that idea. So like a lot of open source projects, once you put an idea out there, and if it's halfway decent, a group of people starts forming around that idea and starts working on it. So these are photos from my now co-founder, Tim. He's over in Belgium, who read the white paper. He emailed me, said, I develop firmware for factory automation. I want to help develop the firmware for the FarmBot. I said, great. So we got him an Arduino and a ramps kit, stepper motor, an old 3D printer, and he kind of turned it into a FarmBot. So there it is, spraying water out. So that was one of the very first prototypes. This is one of my first prototypes, which I used to apply for a grant from the Mark Shuttleworth Foundation. I was very fortunate to get that and be able to continue working on this project with some funding. So we built some prototypes. This is in my makerspace. We started kind of picking up seeds. I think that's actually just a rock, but close enough. Those are actually just a bunch of weeds, but it's a cool photo. Looks like we're growing things. And we started building, more full-scale prototypes outdoors. This is at my house in San Luis Obispo. Meanwhile, my other now co-founder, Rick, he's in Chicago. He was developing the web application, so the control interface for the FarmBot. And eventually, we grew a whole garden. So that's a whole bunch of Swiss chard. That was the first kind of full garden that we grew. We made some delicious raviolis with that. And when we got to this point, this was about the beginning of 2016, our small, still open source, just ragtag team said, hey, we could probably build this into a product and bring this to the market. We had been documenting everything open source up to this point, but there are a very small number of people that were actually taking all of the initiative to build it themselves, but there are a lot of people who are interested in working with the machine. So we ended up making this crowdfunding video. This is actually a shortened version. It's just 1 minute long, which, oops. Is that gonna work? Oh, there we go. So it shows how the FarmBot works, and I don't need to speak because I made it into a meme format, so it tells you exactly how it works without you having to listen with audio. So we post, what was that?
I saw this video.
Oh, perfect. Who here saw the video? Nice. So about half of you. So this thing, we put it on Facebook. We had a crowdfunding campaign on our website going. We said, if you're interested in this, it's available for pre-order. We had never really manufactured anything. We didn't really. That always gets laughs, that scene. One day I need to make some documentation about the fake it till you make it thing. Because there's some funny footage. So. This is actually one of the open source builds that somebody made in Japan, that FarmBot right there. So we put this video on Facebook, and it really just kind of blew up. I think in total, it probably got viewed in about a month's time 100 million times. Let's see here. Ah! Oh. How do we go here? There we go. All right. So this is just an example. It got reposted by a bunch of big Facebook pages. Tech Insider was one of them. So just this repost got 58 million views, 600,000 shares, a whole bunch of comments. It really blew up. It kind of took the world over because it was this brand new idea. People had never seen anything like it. Which was pretty exciting. And in that first month, we raised over $800,000 in pre-order sales. And then we were like, oh great, now we need to manufacture this thing and ship out 300-something pre-orders to people all over the world. And up to this point, we had just built 10 really janky prototypes. So we started kind of doing research. We started working with some contract manufacturers and reviewing sample parts and injection molding stuff and getting motors made with our logo on it and all sorts of stuff, and eventually began manufacturing a whole bunch of kits. This is our first warehouse back in California, and eventually started shipping them out. So the first one went to my mom. So that's on the left is in the FedEx office. On the right is down in San Diego in California. It actually made it all right. And we ended up shipping them all over the world. So this is kind of the first batch of the FarmBot kits and where they went. About half in the US and half everywhere else, including actually one here in Christchurch, St. Margaret's College, which I think is just, well, I'm all turned around, about a few kilometers away, for their tech-to-table program. So that's pretty cool. And just an example of a few of our other customers. This is Garrett and Lexi Sudweeks. We have a little mini documentary on our website about them. They're in Utah, in the United States. They are really into sustainability and being self-sufficient. So they got the FarmBot to grow their own food. There's a nonprofit using the technology as an accessibility tool for people who can't garden like you normally would, down on the ground, out in the garden. NASA actually purchased one to figure out how to grow food in space on the moon and Mars one day. So they kind of got it as something to get inspiration from. So how do we get here? It's really going back to 2013 to the open sourcing of that white paper. Let's see, 1 second. I want to get my speaker notes back up. Where are you? Sorry about that. So it really goes back to the open sourcing of the white paper. But it's not like the white paper was the end-all document. It's not like we built that machine and then called it good and we never updated the documentation again or the source. We're now on version 14 of FarmBot, which is 14 versions later than this mock-up here of the first one. So all the while we were making additions, deletions, changes, and documenting all of that and updating those source files. And that's really what I want to share with you today. All this so far has just been kind of context for where we've come from. Because what's really important is how we've been open sourcing stuff and how we've been documenting, and specifically how we've actually gone beyond what you all are probably used to, which is just the README file. So let's move on here. So this is the README file. Here's a classic one for React, JavaScript framework. In theory, this has everything you need to run that work and do something useful with it. This is tried and true stuff. You all know this has been what we've been doing forever. But not everything is software. FarmBot is obviously a lot of hardware. It's also data. It's community. It's also a business now. So how can we go beyond the README file for these other projects, and there's so many of them out there now, that are not just software, they're hardware, they're communities. How might we go beyond README.md? So open source hardware, that's a big aspect of FarmBot. So I want to just show you really quick what we're doing. This is our hardware documentation hub. So it's at genesis.farm.bot. You can also get there at docs.farm.bot. Oops, sorry about that. So we have all sorts of pages here on the left. You can look at the changelog of what we've changed over those 14 versions. You have your version picker up here. So you can go all the way back to that first version, which many of them are now deprecated. So this is kind of like diffing in GitHub, right? You can see exactly what's changed here. It's a little bit harder with hardware because it's not code, but we do our best to kind of show why we changed things and how we did that. And you get down into the assembly instructions, so how to put everything together. That's a basic aspect of open source hardware, is just how to put the thing together, but even most products that you buy have assembly instructions. So what have we done more than this? In one way, we've released all the CAD models. So this is the source documents for the actual hardware design. So if you go here, we use this really awesome tool called Onshape. It's being created from the founders of SolidWorks. So if you want to figure out, well, what does the watering nozzle look like, and maybe you want to 3D print your own, you can click this and hopefully it loads up fine. And within Onshape, you can measure hole diameters and lengths of things. You can look at the material properties. You can right-click and export to an STL so you can 3D print one of these parts yourself. So here's the watering nozzle. So anyone can load this anywhere in the world. You don't even need an account to view it. Up here is essentially the equivalent of stars and forks on GitHub. So a bunch of people like this, and 2,000-something people have copied this. That's the equivalent of a fork in kind of this hardware system. Over on the left here, you can see that this watering nozzle is part of a whole folder structure of different parts of FarmBot, and at the top level, you have the entire machine. So people can go in here, and you can actually even do this on your phone and look at all of the different hardware. It's pretty cool. Going back, we also have a maintenance guide, troubleshooting. We have a full bill of materials. A lot of people come to us and say, hey, this is really cool, but I'm not in the US, and I want to build this with local materials, and I want to build this with stuff that I can more easily access and don't need to pay a lot of shipping and import fees for. And so in our bill of materials, we have listed before different places of where you can buy stuff, all of the tech specs. So if you want to, okay, let's see. Go into the drivetrain here. I want to learn about the V-wheels. You can click down there and say, okay, look, the bearings that are used are the SS, 625 2RS, where SS equals stainless steel, 625 is the bearing size, and 2RS equals 2 rubber seals. So you can really get in to these documents and learn all about them. We have videos, photos, and it's really accessible. It's really well organized. It's all searchable, and it's all versioned as well. We also have mods and add-ons. So people come to us and they say, oh, I want to power FarmBot with solar. How do I do that? So we have ideas here. It's for inspiration only, it's not guaranteed to work, but these are ideas of how you can do it. I did do it for that FarmBot in the front. So we talk about understanding FarmBot's energy usage, all sorts of stuff. So that's kind of what we've done with our hardware. And when you do this, and you do it well, people start tinkering. They start building their own FarmBots. So on the left there are some students in India building their own FarmBot with kind of a modified indoor-style raised bed. On the right is 2 groups of students who both showed up independently to the same Vex Robotics conference with their own FarmBot projects, which was pretty cool. We have some students at the university I went to that I sponsored who are developing a polar coordinate FarmBot, so it rotates around. So they just, right off the bat, they copied our Onshape files, all the CAD models, and they began modifying them and changing them around to their own project. You have people all over experimenting with it. These are some folks in Amsterdam that I visited. And eventually, people actually compile your source into something useful and run it, and you get this cool output, which is stuff that you can actually eat. And people start sharing it on Instagram and Twitter. Garden Robot has been working hard, nothing like fresh carrots right from the ground. And this one just speaks for itself. Pretty awesome. This is in Japan. All right, so open source community. How can you do that? We actually have a really good example right here at LCA. It's the code of conduct. So huge hats off to the organizers of this event for not only having the code of conduct, but making it very clear that, hey, this is a guiding document. This is the source document for our community. This is really important. It's posted up all over the place. It's on the website. It's in the opening presentations. This is really important. This is the source of a community. So anytime somebody on your team, if you're going to try and adopt a code of conduct, ask them, would you run a library that didn't have a README file? Probably not. Would you join a community that didn't have a code of conduct? Probably shouldn't. So this has been a huge trend in recent years of adopting these. Big thanks to the people at Contributor Covenant. Over 200,000 projects are now using that code of conduct, so it's a great way just to get started quickly. And this is open sourcing how to build a community. So that's really cool. DEF CON, it just came to my attention from Shannon, who told me yesterday, she's another speaker, that DEF CON has transparency reports for how their code of conduct has been enforced. So this is really important. Places to improve in this area, I think, how to actually build a safety team. I selected a few people that I trust, but there's gotta be a little bit more of a process. How do you prevent burnout, stuff like that. Incident case studies, DEF CON is moving in that direction, but I'd like to see, when a certain type of incident happens, what are some steps that I should go through to protect privacy, to protect the safety team, all of that stuff. Open source business is an interesting one. So what does it look like to open source your company? Not just the products, but the actual inner workings of a business. The legalities, the taxes, all that stuff. So this is some steps that we're taking with FarmBot. We actually just announced a new documentation hub for it. There's this great TED talk by Nathan Seidel. He's the founder of SparkFun Electronics. They do all open source hardware, electronic gizmos. And the point of his talk is that if your idea can be sold, it will be. If you take that and you extend it to business, I think it's, if you have a business, you will have competitors. And so, when you look at this and you look at the global economy and all the people out there, what if we just flipped this whole ruthlessly competitive, profit-mongering business world on its head, and we actually looked at our competitors more as collaborators. And we, instead of being afraid of competitors, we actually welcomed them with open arms and said, hey, we're all working towards some common goal here. How can we learn from each other? So we just launched this other documentation hub for FarmBot Inc. itself. You can look at, in case you're interested, how to pay your California sales and use tax, which is quite a convoluted process, but I documented it, and hopefully somebody can learn from that. You can see what vendors we use. You can see, statistics about our products. So you can see stuff like how many units we manufactured, what the cost was to manufacture those, the sales, the margin, the profit, the complexity as it's changed over time. You can get a look into the impact that we're making. We have our documentation style guide. A lot of these things are what you might find on an internal company wiki or maybe be provided to shareholders only, but we're making all this public. You can figure out how we fulfill orders. If you're a hardware business trying to figure out how to ship with UPS internationally using ShipStation, you can look at our documentation and get a little bit more insight into how to do that, because it's not always the easiest to set up these processes, and especially making them streamlined and for specific types of businesses. Our compensation formula, this is actually inspired by an open compensation formula from Buffer, which I'll talk about shortly. Let's see here. Replacement parts and returns. So this is also really good for just even onboarding new employees and training them, because all of it's in this document that's very available for people. Let's see here. So going back to this, I think a lot of people probably are out there being like, you're going to collaborate with your competitors? Like, what does that even mean? But I think it's really valuable. This is how I've built FarmBot to what it is today. I was looking at companies like Buffer and their transparency dashboard. So they share all sorts of stuff. They have a salary calculator. They share their revenues. They share their pricing model, their values. They even have a public Trello board for their product roadmap where people can go in and make requests and see what's going on. This is all really valuable, and I learned a lot from it, and I kind of want to give back in that way. So I guess I already did that demo. I skipped ahead there. So you can look at our company docs at meta.farm.bot. And already, we just published those about 2 months ago, and we've gotten some great feedback. We're thinking about the future of one of our hardware projects, and this is an interesting reference as we move forward. Such a great demonstration of openness. That's from an executive director of a research institute, so kind of a higher up in a larger organization, all the way down to just a person on hackaday.com who's excited about starting a chicken coop operation and automating it. So I think there's a lot of value in sharing these types of things, especially for people who are aspiring entrepreneurs. So what does it all mean? Well, when we open source something, we're giving people power. We're empowering them to develop software, to build hardware, to make communities, and to start businesses. So I'm really, really excited to see what all of you do when you go beyond the README.md. Thank you.
So